The soldering iron is so bad, the tip literally burned itself. So we just encountered our first problem, which was calibrating the ESC. ESC is this little device that actually controls the motor, and it does so by sending different frequencies to the motor, and that pretty much determines how fast the motor should be spinning. But when calibrating the ESC, I didn't put the throttle stick up to a 100% point, which basically lets the ESC set its range, and by that range of frequencies it can actually send signals to the motor. So I guess you should keep that in mind when setting up your ESC, so yeah.
Okay, this should be fine. So, in order for our experiment to actually make sense, we need to explain what we're doing first. So there's this thing called photoelectric effect, and to start the story off, we have two guys. You might have heard of the guy called Newton, and the other guy names is Hook. And these two dudes fought over what light actually is in history. So Newton thought that light acts like a particle, when on the other hand Hook thought that a light travels as a wave. And that was fine until in like 19th century there was this experiment called photoelectric effect that proved that light doesn't act nor as a particle or as a wave. And the first guy who got intrigued by that effect was actually Einstein. And Einstein realized that light actually acts both as a particle and as a wave. So he thought that light actually travels in little packets of energy. So like it's something in between particles and wave. But we have cases where light actually acts both as a wave, as a particle, or only as a wave, or only as a particle. So basically light can be everything, and those little packets of energy today we know as photons. Okay, now for the demonstration. Say we have a metal plate or something, metal whatever, and metal is nothing more than a bunch of ions collected in one place, and we have some decentralized electrons around it, and we shine some light onto it, right? And we start to see electrons popping off. Well, if light actually were a wave, that would happen with any type of light. Like literally, if we have a light bright enough, this would happen. But that wasn't the case in photoelectric effect. And why that is happening is actually determined by the frequency of the light. And frequency of the light is the most important thing in this whole photoelectric effect thing. So because if we don't have a frequency strong enough to release enough energy for the electrons to pop off, we're not gonna experience the photoelectric effect. And that's exactly the proof why wave is in fact a particle. or basically a combination of the two. As particle with enough energy hits the metal plate, it releases or it gives electron enough energy to pop out of the metal. And that's the concept we pretty much need to understand for our experiment to make sense.
So now it's time for an actual demonstration, and first we need to give positive charge onto our can so we can actually see those electrons moving. So you take something plastic, and by induction you can use that to positively charge this. So as you can see, this is now positively charged, and over here we have a completely normal light, and if we shine light onto it we can see that nothing is happening and that our positive charge is not actually going anywhere. But over here we have a UV light, and as you can see, if we shine UV light onto our can, we can see the charge slowly dispersing. And that's exactly what photoelectric effect is. Thank you for watching, and I hope you enjoyed it.